See here the graphs of y equal to a power x and y equal to log x base a when base value between 0 to 1. Clearly, y equal to, in this case, y equal to a power x graph, it is decreasing graph, right? Is decreasing for all x belongs to R. And log x base a also decreasing graph, right? Y equal to log x base a also decreasing for all x more than 0, remember. Only for positive values of x, logarithmic function is defined. So that here you have to write for all x more than 0. Next, in the second case, a power x strictly increasing and log x base a also strictly increasing. We can say strictly decreasing here and here also. Okay. So here I am writing y equal to a power x strictly increasing for all x belongs to R, and y equal to log x base a, it is strictly decreasing for all x belongs to open 0 to infinite. That means x more than 0, right? And remember, inverse graphs, they are symmetric about y equal to x. This is y equal to x, right? This straight line. See the points, they are symmetric about y equal to x, right? This is f and this is f inverse. Or if it is f inverse, then it is f. The same way here also. The points are symmetric about y equal to x, right? Here and here. Okay. This is about exponential function and logarithmic function. Next, we will discuss about trigonometric functions. Graphs of trigonometric functions we are going to discuss now. First, I am selecting y equal to sin x. We know that sin x is defined for all x belongs to R, and the graph of sin x x-axis, it is y-axis. Here it is 0. Assume that this is pi by 2, and here it is pi. Next, third pi by 2. Fourth pi by 2 means 2 pi. Fourth, next fifth pi by 2 it is 6 pi by 2 means 3 pi. Okay. In the same way, 1 minus pi by 2. Second minus pi by 2 means minus pi. Next, minus 3 pi by 2, minus 2 pi, minus 5 pi by 2, and then minus 3 pi and so on up to infinite, up to minus infinity. Okay. Assume that this is 1, this is minus 1. We know that sine 0, 0, sine 90, 1, sine pi 0, sine 3 pi by 2 minus 1, sine 2 pi 0, sine 5 pi by 2 1, sine 3 pi again 0, sine of minus pi by 2 minus 1, sine of minus pi 0, sine minus 3 pi by 2 plus 1, sine of minus 2 pi 0, and minus 5 pi by 2, sine of minus 5 pi by 2 value minus 1. By joining all these points, we get the graph of sin x. This is the graph of sin x. Okay. Next here, this one. This is the graph of y equal to sin x. And clearly, domain is set of all real values, and range of the sine function, that is from -1 to 1. And it is periodic function whose period is 2 pi. See the graph. The graph of sin x up to in this interval, whatever the graph you have, the same graph that repeats from 2 pi, right? See this one. At origin, it is 0, and at pi by 2, 1. So it starts like this. The same graph repetition occurs first at x equal to 2 pi, right? The least positive real number where the same graph starts like origin. That is known as period of the function. So that its period is 2 pi. Next. Okay. And clearly it is continuous function. No gaps, right? Therefore, I can write it is continuous on R. No sharp edges. Therefore, it is also differentiable on R. No jumps and no gaps, no sharp edges, right? Therefore, it is also differentiable on real line. And the principal boundary of this function is from minus pi by 2, pi by 2. This is the principal boundary or principal domain. Principal domain is nothing but in that interval, the graph satisfies the function satisfies both 1, 1 and on 2 conditions. See, in the interval minus pi by 2, pi by 2, it is strictly increasing, right? Therefore, different values of x having different images. Therefore, clearly it is 1, 1. And codomain equal to range in the interval -1 to 1. Therefore, only from minus pi by 2, pi by 2, if you see the graph, it is bijective. Therefore, principal domain can be written as minus pi by 2 to pi by 2. Okay. This is about the graph of y equal to sin x. And in the same Cartesian system, I am going to explain the graph of y equal to 1 by sin x. That means y equal to cosecant x. Let us see. Sine graph range from -1 to +1. Now we are going to draw reciprocal graph. That is y equal to 1 by sin x. That means y equal to cosecant x. Let us see reciprocal values of sin x. Observe here, X is clearly x0 means y0, right? Sign value here 0. When you substitute sign value 0 in this, y become infinite. Next, x value suppose pi by 2, then sin x value 1. Reciprocal of sin 1 by 1, that become 1. Okay. Next, suppose here on the graph of sin x, here y value 1 by 2. Its reciprocal become 2. Here y value suppose 1 by 2. Its reciprocal become 2. And 0 means 1 by 0, not defined, right? That approaches to infinite. So that there is a gap at x equal to pi. When you write x equal to pi, sin pi value becomes 0. 1 by sin pi means 1 by 0, that approaches to infinite here. Next, it is not defined at x equal to 2 pi also. Why? Because sin 2 pi 0. Right? In the same way, here it is not defined at x equal to minus pi and minus 2 pi. Okay. Next, observe here. Here, sin x value minus 1, its reciprocal 1 by minus 1 become 1. Suppose here it is minus 1 by 2, y value. Its reciprocal become minus 2. Next, minus 1 by 2, here the value of sin x. Its reciprocal 1 by sin x means what we get? Minus 2. Therefore, and clearly approaching to pi, it is not defined. 1 by sin pi, 1 by 0, not defined. Therefore, we get the graph in this way. In the similar way, you can draw the graph here and here. Just the reciprocals I am going to draw. This is the graph of y equal to cosecant x, right? And for this graph, what is domain? Observe, it is defined for all x belongs to r minus n pi. Why? Because at pi not defined, at 0 not defined, 2 pi not defined, 3 pi. At 3 pi also it is not defined. Why? Because sin 3 pi becomes 0. Okay. So that domain can be written as r minus n pi, where n belongs to integer. And see the range of the function. The interval in which sine function is defined, there is no graph of cosecant x, particularly it is at x equal to 1 only, right? Starts from 1 and reaches to infinite in the above x-axis. And in the below x-axis, it starts at minus 1 and approaches to minus infinity. Therefore, I can say that range minus infinite to minus 1, union 1 to infinite. And period of the function. The same graph which is at origin, it starts at 2 pi here. Here U-shaped graph at x equal to nearby origin, you have U-shaped graph. And the same graph starts from 2 pi, right? Therefore, its period is 2 pi. Clearly, the graph discontinuous, right? At pi, 2 pi, 3 pi, there is a gap. Therefore, I can say that it is continuous on r minus n pi. On respective domain, it is clearly continuous. Okay. And next, differentiability also same. It is differentiable on r minus n by n belongs to z. And observe the principal domain. Principal domain means nearby origin where the function is bijective. Observe this one. Observe the part. See, here it is strictly decreasing and strictly decreasing, but it is not defined at x equal to 0. And in this interval, clearly it is bijective. Therefore, I can write principal domain from minus pi by 2 to pi by 2, open, sorry, close brackets, except 0. This is principal domain of cosecant x. This is about the graphs of sin x and cosecant x. Next, we are going to discuss about the graphs of y equal to cos x and its reciprocal graph 1 by cos x, that means secant x. Let us see the graphs of y equal to cos x and y equal to 1 by cos x, that means secant x graph. X axis, y axis, and this is origin. Suppose here pi by 2, pi, third pi by 2, fourth pi, third pi, like that. First pi by 2, second, first minus pi by 2, second minus pi by 2 means minus pi, third minus pi by 2, fourth minus pi by 2 means minus 2 pi. Next here it is minus 3 pi. Assume that it is 1 and it is minus 1. Now substitute the values of x equal to 0 first. Cos 0, that is 1. Cos pi, minus 1. Cos 2 pi, again plus 1. Cos 3 pi, minus 1. Cos of minus pi, nothing but cos pi, again minus 1. Cos of minus 2 pi, cos 2 pi, that is plus 1. 3 pi here. Okay. That means we get the graph in this way. Okay. This one is the graph of y equal to cos x. And I can write from this clearly domain, set of all real values, and range of this function from minus 1 to 1. Here it is y equal to 1. And this is y equal to minus 1. So range over. Next, it is periodic function and whose period clearly 2 pi. Observe the graph. The graph which is in the principal domain, not in the principal domain, the graph which is nearby origin, that repeats again at x equal to 2 pi. Repetition starts at x equal to 2 pi, so that the least positive real number 2 pi here, so that I am going to write period 2 pi. It repeats at 2 pi and then at 4 pi also. But the least positive integer, sorry, least positive real number is called period of the function. Therefore, period equal to 2 pi. Okay. And next, clearly the graph is continuous, right? There is no gap, no jump, right? And no sharp edge. Therefore, it is continuous graph on real line. And also it is differentiable on R. Next, I'm going to write principal domain. What is principal domain of this function? Observe where the graph bijective. See here, this is the region in which the function strictly decreasing, right? Bijective also. So that 0 to pi is its principal domain. Therefore, principal domain I am writing close to 0 to pi. Okay. Next, we are going to discuss about the reciprocal of cos x. That means the graph of secant x. Just to substitute the values of cos x in this y equal to 1 by cos x, that gives secant x. See here, when you write x value, suppose 1, sorry, x is 0 means cos 0 1. Therefore, 1 by cos 0, that becomes secant 0 1. Okay. Next, when you write x value pi by 2 here, then cos 90 0. 1 by cos 90 means 1 by 0 not defined. Therefore, the graph does not exist at x equal to pi by 2. And then third pi by 2 also, it does not exist. Next, at fifth pi by 2 also, it does not exist. And here at minus pi by 2 also, it does not exist. And here, so for all odd multiple of pi by 2, secant graph does not exist. And observe in the interval, here cos x value 1. Therefore, 1 by cos 1 reciprocal secant y equal secant x value also 1. Next, suppose here cos x value 1 by 2. If you write cos x value 1 by 2 in this, y value become 2. Here cos x value 1 by 2. 0 to 1, in between 0 to 1, 1 by 2 if I select, then its reciprocal become 2. And clearly here cos x is 0. If you write 1 by cos 0, sorry, 1 by 0, that is not defined. Therefore, you will get the graph in this shape. Okay. In the same way, when you write minus 1 only, reciprocal, this is not sharp U-shaped graph. Next, when you write minus of minus 2, here minus of cos x value, minus 2 we get. Joining all these points, we get a reciprocal graph in this way. In the same way, here we get the graph like this. Next, in this interval. Okay, and here it is like this. And next, we get the graph in this way. And here there is a gap. Okay. Next here. And here there is a gap. This is about the graph of y equal to cos x and secant x. And now, what is domain of secant x? This is about related to cos x. Next, secant x domain. What is domain of secant x? R minus odd multiple pi by 2. That means 2n plus 1 pi by 2, where n belongs to z. Clearly, there is a gap, particularly at odd multiple pi by 2, so that in general I am writing r minus 2n plus 1 pi by 2 is its domain. Next, range of this function from minus infinite to minus 1. Here open it is and it is closed. Union 1 to infinite. Next, period of this graph. It is also 2 pi. Let us see the graph which is started at origin, the same graph at 2 pi. Again it starts, right? This one graph and the same graph in starting at x equal to 2 pi. Therefore, least positive real number 2 pi. It starts again at 4 pi also, but least positive integer is called period, so that 2 pi. Next, the graph is continuous at respective domain r minus 2n plus 1 pi by 2. So it is discontinuous at odd multiple pi by 2, I can write. It is discontinuous at x equal to 2n plus 1 pi by 2, where n belongs to z. Also, differentiability. Okay. Next, principal domain for this. Principal domain from 0 to pi, but not pi by 2. Let us see the principal domain of this graph. This one. Observe in this interval, see, strictly increasing, and there is a break at pi by 2, and then strictly increasing. Increasing as well as increasing, right? Only there is a gap at x equal to pi by 2. Therefore, I can write principal domain of this function, principal domain, that is from 0 to pi except pi by 2. This is about the graphs of y equal to cos x and y equal to secant x. Next, we will discuss about the graph of y equal to tan x and y equal to cortex. Next graph y equal to tan x and its reciprocal graph y equal to 1 by tan x, that is equal to cortex. Suppose this is 0 and it is pi by 2, pi, next third pi by 2, fourth pi by 2, next fifth pi by 2 it is. Similarly, minus pi by 2, minus pi, minus third pi by 2, minus 4 pi by 2, next minus 5 pi by 2. The graph of tan x is not defined at x equal to odd multiple pi by 2. Why? Because tan 90 not defined, right? Therefore, take a dotted line here at x equal to pi by 2. And at for every odd multiple pi by 2, the graph of tan x is not defined clearly. Okay. There is a gap at these particular places. Okay. Next, tan 0, 0, tan pi by 4, 1, tan 90, now define, approaches to infinite. Next, tan of minus pi by 4, minus 1. Next, tan of minus pi by 2 approaches to minus infinity. This is the graph. Next, 2 pi 0. And again, the same graph repeats like this. By substituting the values, we get the graph of tan x like this. This is the graph of tan x. Next, I'm going to write domain. Clearly, domain is r minus odd multiple pi by 2, 2n plus 1 pi by 2, such that n belongs to z. Next, range. Range is from minus infinite to infinite, or set of real values. Why? Because it is strictly increasing graph, right? It is strictly increasing graph on its domain. Okay. Next, period of the function I am going to write. The same graph which is at origin, at that is started at x equal to pi. Therefore, period equal to pi. Okay. Also starts at 2 pi, but we have to select least positive real number. That is, pi is period of this function. Next, principal domain. What is principal domain? In the interval minus pi by 2 pi by 2, it is strictly increasing, bijective, right? But open minus pi by 2 and open pi by 2, you have to write. Why? Because the graph does not exist at pi by 2 and minus pi by 2. Next, this is continuous and differentiable in its respective domain. It is continuous and differentiable in its respective domain. That means where it is defined, there that is differentiable and continuous. Clearly, the discussion on discontinuity at x equal to 2n plus 1 pi by 2, such that n belongs to integer. Okay. Yes, discontinuous at first pi by 2, third pi by 2, fifth pi by 2. That means odd multiple pi by 2. Next, to draw the graph of cortex, reciprocal of tan x, right? So that when tan x is 0, cortex become infinite. Therefore, it is not defined, cortex not defined where tan x equal to 0. Why? Because to define cortex, the condition tan x should be non-zero quantity. Therefore, it is defined only on r minus n pi, where n belongs to z. Cortex is defined at r minus n pi. Therefore, this is known as domain of cortex. And range. Range is from minus infinite to infinite. See, particularly at 0, it is not defined. And at pi by 2 tan graph, here not defined. Okay. When x is pi by 2, tan pi by 2 not defined, but cortex is defined. Why? Because 1 by infinite that become 0. Particularly at pi by 2 it is 0. but at pi it is not defined. And at x equal to pi by 4 it is 1. So, and at 3 pi by 4 it is minus 1. So that we get the graph of cortex, blue colored one. In this way it exists. Next, at 2 pi it is not defined. Okay. So now in this boundary, we get the graph in this way. This is the graph of cortex, blue colored. Next, here it is not defined. Okay. And the graph of cortex, we get like this. This blue colored diagram represents the graph of cortex. And observe, period is pi. Why? Because the graph which is nearby origin, that is same as, again it starts at x equal to pi. Therefore, period of cortex is pi. And clearly, on their respective domain, it is continuous and differentiable. Discontinuity, clearly at x equal to n pi, where n belongs to z. Next, principal domain. What is principal domain? Observe, the principal domain of this function is clearly this part. Okay. From 0 to pi, it is strictly decreasing. Open 0, open pi, and it is strictly decreasing graph. Strictly decreasing graph it is. Okay. And it is strictly increasing here. Tan graph is strictly increasing, chord graph is strictly decreasing. This is about the graph of tan x and cortex. In the next session, we will discuss about the graphs of inverse trigonometric functions.